Okay, table probabilities can be a little confusing, but it kind of makes sense where you would use this, right? That if you have this table data. So it says, what is the probability that a consumer is 18 to 24 years of age given that she dislikes crunchies? So I always go back to the given formula. So they're 18 to 24 given they dislike crunchies. So the formula for a given is the probability these both occur. So an and dislikes divided by the probability of the given. So now I can simply go to my table and I can find the probability 18 to 24 and they dislike, which would be that 8 right there, 18 to 24. And then, if you write the true probability, it's 8 out of 200, but you're going to see the 200s cancel. And then the probability they dislike would be 32 out of 200. And as I mentioned, the 200s cancel. And I can reduce that, divide the top and the bottom by 8 to get 1/4. All right, what's the probability that a selected customer dislikes crunchies? Let's get another color going here. So that they dislike, so the probability they dislike, I think would just be the 32. So probability dislikes 32 out of the total 200. I saw that I could divide both of these by 4, so I reduced and I got 8 over 50. And then I'm like, oh, well, I can still reduce that by 2 and get 4 over 25. So all I'm doing is just simply reducing the fraction. All right, let's see what we got next. Give me another color going right here. Ooh, we'll go orange. All right, what is the probability the selected customer is 35 years or 35 to 55 or likes crunchies? This one you have to be careful with. So the probability they're 35 to 55 or they like crunchies is the same as the probability they're 35 to 55 plus the probability that they like minus the probability of the intersection. And this is important, and you'll see this here in a second. So this is the and. Sorry, I'm trying to squeeze that in. All right, so the probability that they're 35 to 55. So that looks like that would be that number right there, 27. These are all out of the total, 200. The probability that they like crunchies, I don't even know what crunchies are, is, oh, I guess it's a snack food. You can tell I didn't read it, huh? Is the total 75 over 200. Now think about when you read this table. So you went straight across here to get that total. Then you went straight down. Do you notice what happened? That piece right there got counted twice, and that's the and hence why you subtract that piece out. So all same denominators, I added and then subtracted the 13, and I got 89 out of 200. 89 out of 200. All right, almost there. Got to the last one. We'll get a blue. All right, if a selected consumer is 70 years old, that's the given. So what is the probability he or she likes, given that we know ahead of time that they're 70 years old? So in this case, I can actually, if I clean my table out here, I can just simply look that I know, okay, so in this case, that they are 70, which means they're 55 and older, and they like crunchies. So I don't really have to do too much here, but you have to be careful with the given part. They were given, and so I get the 17 over 68. Once again, you could do this the same way that, like as I did up here, the probability that they like and would be 17 over 200 over the 68 over 200, the given. And again, I get these tables are really confusing, but if you always start with the definitions, okay, so remember that the given is the probability and over the probability given, and then the or. And I think this makes sense. We always say you always subtract the intersection and nobody knows why, but I think it makes sense with the table because you could see you counted it twice.